Today we're on page 4 of the Chapter 13 AP Chemistry packet on equilibrium. We're going to continue talking about the reaction quotient Q, and this time we're going to need to use the quadratic equation to solve in order to find the equilibrium concentrations of reactants and products. So in this problem, I'm giving you an equilibrium of hydrogen iodine and hydrogen iodide. I'm telling you the Kp is 100. I'm giving you an initial amount of each of the reactants and products. And the first question is this at equilibrium or not? So in order to do that, we do Q. Q is a test. It's set up exactly like the equilibrium constant. So in this case, it's going to be the pressure of the products, which is HI, raised to the second, over the pressure of the hydrogen raised to the first, times the pressure of the iodine raised to the first. So we're going to plug in the numbers that we got. So without going crazy with sig figs, I'm just going to write this 0.5 squared over 0.01 times 0.005. And then what you do is you just check your sig figs at the end. So do all this and you get Q equal to 5,000. Okay, so this is Q. Now a little trick, if you really are having trouble with understanding how to compare Q and K, start with the K on the left and the Q on the right. Okay, so what is the K? The K is 100. What was the Q? 5,000. So then show which one is greater. The Q is greater. So you're going to go like this. Q is greater than K. So this arrow right here, or rather the greater than sign or less than sign, in this case the less than sign right here, this is going to tell you in which direction to shift. So you would point that way. So it's shift to the left. Okay, so once again, if you're having trouble with the Q and K comparison, just put the K first, start with K, Q on the right, put them down, put the less than or greater than sign, and whatever that sign is going to be the head of the arrow telling you in which direction the equilibrium is going to shift. So this is going to shift to the left. So now what we have to do is we have to make a chart of ICE, an ICE chart as we call it. Again, we put our initial amounts right here, and then we're going to shift left. If we're shifting left, that means that the right side is going to decrease. So we're going to minus, and remember the change line follows the ratios of 1 to 1 to 2. That's really important. So this is going to be a minus 2x because there's a 2 right here. But this is going to be a plus x because there's a 1 right there. And this is going to be a plus x because there's a 1 right there. So you really have to pay attention. So when you're all done, you're going to have, I'm just going to write 0.01 here plus x, and here I'm going to write 0.005 plus x. Again, we'll do the sig figs later, and this is going to be 0.5 minus 2x. So those are going to be my equilibrium concentration. So whenever you have equilibrium, that's when you could put it into the equilibrium expression. So let's review again what this expression is going to be. It's going to be the pressure of HI squared over the pressure of H2 times the pressure of I2. And when you put your numbers in, you're going to get a 0.500, all right, whatever, there's this extra sig figs, minus 2x squared over 0.01 plus x and 0.005 plus x. So there it is. Now I have a giant mess. So what I'm going to have is, to write this down, I'm going to have Kp, which is 100, equals, now in the numerator, as you remember from algebra, you're going to have 0.5 minus 2x times 0.5 minus 2x because it was squared. In the denominator, you're going to have a 0.01 plus x and then a 0.005 plus x. And now you need to remember the FOIL method from algebra, where you have to take the firsts and the outers and the inners and the lasts. So that's FOIL. Okay, so you're going to do that for each of these. And I'm going to go ahead and do this with you because it does get rather cumbersome. If you can do it on your own, that's awesome, but here it is in case you're going to need some help. So we're going to do the firsts on the numerator. I'm going to give myself a little room here. So on the numerator, I'm going to do the first. 0.5 times 0.5 is 0.25. Okay, then I'm going to do the outers. So that's 0.5 times -2, which is -x. -2x it was. All right, I'll point. First, 0.5 times 0.5 is 0.25. Next, I'm going to do outers. 0.5 times -2x. That's going to be a -x. Then I'm going to do the inner, which is 0.5 times -2x. So that's going to be also a -x. And then I'm going to do my lasts, which is -2x times -2x, which is going to be positive 4x squared. Okay, do the same thing for the denominator. First, our 0.01 times 0.005. That comes out to be 5 times 10 to the -5th. Then you're going to do your outers, 0.01 times x, which is going to be 0.01x. Then you're going to do your inners, which is going to be x times 0.005. So it's going to be plus 0.005x. And lastly, sorry, these are coming out a little strange. Lastly is the last, and you're going to have x times x. So that's going to be an x squared. And that all equals 100. Okay, so now what you need to do is you need to simplify and combine like terms. So on the numerator, you're going to have 0.25 minus 2x plus 4x squared. In the denominator, you're going to have 5 times 10 to the -5th minus, plus 0.015x plus x squared. That's going to be the denominator because you combined the x terms. You combined the 0.1x and the 0.005x. That makes 0.15x. Okay, and that still equals 100 on the left side. And now you're going to need to multiply this whole thing on both sides. All right, so that is going to get multiplied by 100 on the left side. So when we do, I'm going to skip a step and just because I'm not going to have enough room. So once again, I'm going to take this whole denominator. I'm going to multiply both sides by this. So over here, if I multiply it, this will divide out. And then this gets multiplied over here, so I'm going to multiply by 100. So what I'm going to end up with on the left is going to be a 5 times 10 to the -3rd plus 100 times 0.015 is 1.5 for the x. And then 100 times x squared is going to be x squared times 100. And then the right side is going to be the same as it was before, which is 0.25 minus 2x plus 4x squared. Okay, so now what we have to do to use our quadratic equation, we're going to set this equal to 0. So to set it equal to 0, you're going to combine like terms. So I'm going to subtract this number from the 0.25. I'm going to subtract the 1.5x from the -2x. I'm going to subtract the 100x squared from the 4x squared. So when it's all done, I'm going to write it in the right order for quadratic. So I'm going to do the x squared first. So this is going to be -96x squared minus 3.5x plus 0.245 as my constant. And then if you want to start it off with a positive, you could multiply everything by -1. So this becomes positive 96 x squared, positive 3.5x, and negative 0.245. And now I'm able to use my quadratic equation. So I bet you thought you were never going to have to use this in your life. Well, here we are. Quadratic. So the quadratic equation, as you know, hopefully, is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So your a value is going to be positive 96, your b value is going to be positive 3.5, and your c value is going to be negative 0.245. So this is going to be equal to negative 3.5 plus or minus the square root of 3.5 squared minus 4 times a, which is 96, times c, which is negative 0.245. And that's all going to be divided by, the whole thing is going to be divided by 2 times a, which is 2 times 96. Okay, I'm going to trust that you can do this in your calculator correctly. And you're going to get two answers for x. Okay, one of them is negative. Whatever that negative answer is not right. And the positive answer is going to be 0.035. So there's my x. All this work was to get x. So positive 0.035 is my x. So now what I can do is put that back up top. So this is going to be 0.01 plus x is going to be 0.045 atmospheres, because the x was 0.035. And then over here, this x is going to be 0.040 ATMs. And then this 0.5 minus 2x is going to be 0.43 ATMs. So in black are my final pressures at equilibrium of the hydrogen, the iodide, and the hydrogen iodide. And lastly, you should do a double check just to make sure that this makes sense. And my double check is going to be putting it into the Kp expression. So Kp is going to be 0.43 atmospheres squared divided by 0.045 ATMs to the first times 0.040 in the denominator. And when you do that, you're going to get an answer of 103. And 103 does check out with the actual Kp of 100. So there's a match. So therefore, we did do this correctly, and we found it. So here's the 30-second recap. We started with a certain amount of hydrogen, iodine, and HI, and we didn't know if we were at equilibrium, so we did a Q, which is a test. We found the Q to be 5,000. When you compare K to Q, Q is larger, which means that you have to shift left. So when we did that, we had to introduce our ICE chart, and shifting left meant that we took away from the products and made the reactants. It had to follow the 2 to 1 to 1 ratio in the change line. It always follows the stoich. We ended up with our equilibrium information right here in blue. We put that into our expression. We ended up with this algebraic mess, which we had to apply the FOIL method for. So we did all our math over here, and then we finally got it equal to 0 equals something. We got our A, B, C. We stuck that into the quadratic equation. It always gives you two answers. One of them, if it's negative, is no good, and the other answer is the right answer. We did a double check, and we found out up here that this did match. This matched the K once we did the numbers, so we did the right answer. Lastly, I forgot to mention this before. If when you're doing your x equals and with your quadratic, and you find out that they're both positive, which could happen, both of these could be positive, one of them is not going to work. For instance, let's suppose both of these came out to be positive. One was 0.035, but the other one was a number that didn't work over here. In other words, it was a big, let's call it 0.1 just for ease. Okay, so if you took this very small number minus 2 times 0.1, you would get a negative number down here. So mathematically, that's not going to work. So even if the answers are not negative themselves, they're going to, one of them won't work in your ICE chart, and you'll see that it's the wrong answer.